Hello and welcome. Today we're going to be solving the problem logical moves. In this problem, we're given a phrase containing these four words, so true, false, or, and our goal is to replace all words from some position L to some position R with a single Boolean value, true or false. And then our goal is to determine if we can make the resulting expression evaluate to a certain Boolean value. So this is an interval casework problem. These are often some of the most challenging USACO problems there are. And the way you approach these problems is you need to gain a good intuition for the question by working through lots of test cases. So let's take a look at a few examples. Here we're given a phrase with the words true, false, and or. And we're given a couple different objectives. So here we're replacing every word from the first word to the seventh word, and our goal is to make the resulting expression false. So let's highlight everything from the first word to the seventh word, and I'm just going to replace that with the word false. So when I do that, this entire expression becomes false or false and false. We evaluate the and first, so that becomes false and false is false. And then we have false or false, which is false. So the whole thing evaluates to false. So we were successful in reaching our goal, right? We wanted to create an expression that evaluated to be false. But it's not always going to be possible to reach our goal. Let's take a look at the second example where we're now going to replace the words from position 3 to position 9. So we're replacing this sequence of words. And sort of if I want to make the expression false, sort of the best thing I can do is replace those words with the word false. And when I do that, I get true or false and false. So when I update these, so false and false becomes false. So I get true or false, which is true. So I failed in my objective, right? I wanted to create an expression that was false, but it didn't end up being possible. So I would print no in this case. Another example of a failure would be if I have L is 1 and R is 9, but I want to replace everything such that the statement becomes true. If I replace these words, so from 1 to 9, with the word true, then I am left with the expression true and false, which we know evaluates to false. So I get another failure. So the only way of sort of tackling this question is twofold. One, you could actually just replace the text with true or false, see what the expression evaluates to, and then print out the corresponding answer. Unfortunately, the size of the phrase and the number of queries you're answering is so large that this ends up being far too slow. Therefore, we're going to need some way to instantly determine whether or not we are going to be successful or we are going to fail. So here we're going to break down some casework and try to identify what is important to the problem. All right, so let's analyze this test case and see what we can make of it. So here we have true or false and true or false and false. And what I want to highlight is since and statements get evaluated first, the or statements in the expression sort of create the bounds to various intervals, right? So the and statements will all get evaluated first, and what remains will just be a series of or statements. So we can condense down all of these and statements into just the resulting Boolean expression. And the key idea is that if a series of and statements has even a single false, right? So if I had true and true and true and false and true, it doesn't matter that most of these expressions are true. If I have even a single false in there, the resulting expression is going to be false. So I'm just going to look at all of these different intervals of and statements, and I'm going to collapse them down to their resulting Boolean expression. So if I do that, I see that the first interval is just true, false and true becomes false, true is just true, and false is definitely false. So let's think about what needs to happen in order for true to be, or for the statement to be true at the end of the process. In order for the statement to be true, either one of the following two things has to happen. So at least one of the true intervals remain. So we have two intervals that are true here. If one of those is untouched by our removal process, then we know that the statement is going to be true. Because if we have even a single true statement, true or false or false or false or false is going to be evaluated to true. All we need is just a single true statement. So as long as one true statement remains, the expression is going to be true. The alternative is that all of the true intervals get removed, but then a new true interval is created, right? We get to add in a new Boolean value. So if a new true interval is created, then the statement will also evaluate to true. On the flip side, the statement evaluates to false if all true intervals are destroyed, right? So we would need to get rid of this true interval and this true interval in order to have a chance at the statement being false. So let's take a look at a larger test case and try to identify some patterns that we notice. This slide looks a little complex, but let's break it down piece by piece. So first of all, I have these two arrays. So I just have a phrase of true and falses. I'm representing them as T's and F's just to be a little bit more condensed here. And I have a good start and a good end array. What these represent are good places to start and end my the chunk I'm removing if I want to make the overall interval true, right? So if I want to create a new true interval, good start and good end are going to tell me where it is possible to create a new true interval. So here we can see that this is already a true interval, right? So I just have true and true and true. So that would evaluate to true. So everywhere that I'm already in a true interval, I can start or end there. So I can remove those, and that's going to be just fine. For intervals where I have where the result is false, right? So these false intervals, it gets a little bit more complicated. I can start anywhere before and including the first false value. So if I start my removal here, that's okay. If I start my removal here, that's not okay. Why is it not okay to start my removal here? Well, if I start my removal here, this false will still be present in the interval, and therefore the whole interval is going to evaluate to false. So if I want to make sure that the interval I'm trying to create is a true interval, I need to make sure my start is going to remove all potential falses in the interval. So it's okay to start here, not okay to start here. On the flip side, if where I'm ending my interval, it needs to include all of the falses in the bad interval. So if I end my interval here, right? So say I grab this interval, this isn't helpful because this false is still hanging around. Whereas if I grab this interval, now all the bad falses have been removed, right? And now if I replaced the highlighted expression with a true, I would get a true interval ranging from here to here. So the good start interval array is just going to be 1 whenever I haven't reached the first false value. And then the good end array is going to be 1 whenever I reach this last false value and beyond. Here we have another true interval, right? True and true is still true. So good start and good end are both going to be 1, right? I can always sort of turn a true interval into another true interval. There's no sort of problems there. And then here we have another false interval, right? False and false and false and true is going to evaluate to false. The first false is here. So the only place I could start in this interval is here. The last false is here. So I have 2 ending locations. So if I replace this with a true statement, I get a true interval. If I replace this with a true statement, I get a true interval. But if I do anything else, like if I do this, if I replace this with a true, I would still get a false, right? True and true is still false. So this interval is just marking where I can possibly start my removal and end my removal in order to create a new true interval. And the key observation is that if good start L is 1 and good end R is 1, then I can create a new true interval if I want to by replacing everything from L to R with the Boolean value true. So this handles the case of creating a new true interval. All that we have to do is determine whether or not a true interval remains when I remove L to R, right? So if one true interval remains, then we can make it true. If one true interval remains, then we definitely can't make it false. So in order to determine if one true interval remains, we're going to record 2 very important locations, minimum and maximum. So minimum is going to be the last true in the first true interval, right? So this is the first interval that's true. And minimum is the location of the last true in that interval. Maximum, on the other hand, is the first true in the last true interval. So this is the last true interval, and this is the location of the first true in the last true interval. If L is greater than minimum, that tells me that the first true interval has not been destroyed. If R is less than maximum, that tells me that the last true interval has not been destroyed. So therefore, if L is greater than minimum or R is less than maximum, at least one true interval has to survive the removal process. So what this does is it breaks it down into 2 cases. So the first case, if my goal is true, then I want to check either is good start and good end both equal to 1. If they're both equal to 1, then I'm happy. Or on the other hand, if L is greater than minimum or R is less than maximum, then I'm happy. If the goal, on the other hand, is false, then I need both L to be less than or equal to the minimum and R to be greater than or equal to the maximum. So if either of these conditions are true, then I'm going to print yes. If they're both false, I'm going to print no. Again, doing this casework is fairly challenging, right? Coming up with these ideas, very hard, which is why in these casework interval problems, it's so important to write out test cases by hand, right? So the way you should approach questions like this is just sit down with a pencil and paper and write out test case after test case after test case until you can personally identify what is important in the problem. All right, we're now ready to begin coding up the problem. We're going to begin by reading in our input N and Q. These are just the length of the phrase and the number of queries we have to answer. Then we're going to read in the phrase as a string array, and I'm choosing to add 2 extra values to it, just an extra or false. This won't change the result of anything. It's just going to make handling the last interval a little bit easier. But there are other ways of handling this problem as well. Next up, we're going to set up a series of important variables. So first up, we're going to declare minimum and maximum. Minimum should just start at a large number. So this is Python syntax for 1 billion. And maximum should just start at a small number. Next up, we're going to create our start and end arrays. And remember these, if start and end are both equal to 1, then the phrase can be true. So we're just going to start them all at 0, and then as we get evidence for what the right value should be, we're going to fill them in with 1s as necessary. Next up, we have a last false and interval start. So last false is just going to record the position of the last false value in any interval, and interval start is just going to record the start of each interval. So here we are going to loop over all the phrases, so all elements of the phrase, and we're going up to n here because I want to reach this last or statement. So I'm using ors to sort of denote when the intervals are ending, which is why I wanted this extra or on the end of the phrase array. So the first thing I'm going to check if a last false is equal to -1. If this is true, that means I have not yet found a false in my interval, so I should keep setting start I to be 1. And just to prevent an overflow error, we're going to make sure that I is less than n here. Next up, we're going to check if the phrase is equal to false. If the phrase is equal to false right here, then I'm going to update last false. So this is just saying, okay, I've found a new false in my interval, and I'm going to update the last false variable with just the position of the most recent false. Then, once I've reached an or, this tells me that the interval I'm in is about to end and I have a bunch of work to do. The first thing I want to check is if last false was never changed. This means that we found no falses in the current interval. So if we found no falses in the current interval, that means this is a true interval. So we need to update the minimum and maximum values. So the minimum value is going to be updated to the last element in the current interval. Maximum is going to be updated to the first element in the current interval. And we just take the maximum so that max ends up being as large as possible, and we take the min so that minimum ends up being as small as possible. Note that if we only have one true interval, it's a little bit strange. Minimum can actually be larger than maximum, but that's only in the special case where you have exactly one true interval. All right, the next thing we want to do is update the end array. So we already updated the start array as we went along, but now it's our chance to update the end array. So we're going to update the end array from either interval start to I or last false up to I. So this is just going to loop over the array, the end array, and set everything after the last false to be 1. If we never found any values of false, then we're just going to start at the beginning of the interval and loop up until the end of the interval. And then finally, we're going to set up our values for the next interval. So going into the next interval, we're going to set last false back to -1, and we're going to declare the interval start to be I plus 1. And so this completes filling in all of our important variables. Now we just have to use them to answer the Q queries that we've been given. So we're going to read in L, R, and our objective. We're going to turn L and R to integers, and we're going to subtract 1 from both of them. Note that by default, L and R are 1 indexed, so they're values from 1 to n. But in order to interface with our array, we want to subtract 1 from them, so we want them to range from 0 to n minus 1. Now we have to do a little bit of casework, and the casework is exactly as I've written here. So the first case is if our goal is true, then we want to, if our goal is true, then we're going to check first, can I add a new true interval, right? So is start L equal to 1 and end L equal to 1? If we can add a new true interval, then we know that we're going to be able to print true. Otherwise, we want to make sure that we haven't removed all of the true intervals. So if L is bigger than minimum, then we know that the first true interval must still exist. If R is less than maximum, then we know that the last true interval must still exist. So if any of these three conditions is true, we know that the resulting expression will be evaluate to true, and we can print yes. The important thing here is that all of these checks are extremely quick operations, right? This check can be done in constant time. If this took any significant amount of time, our program would be too slow because the number of queries here is large, right? I believe it's 200,000. So we need to make all of these checks very quickly. And that's why we did all of this pre-computation in order to speed up these checks. The second case is when the goal is false. When the goal is false, we need L to be less than or equal to the minimum and R to be greater than or equal to the maximum. So this is going to destroy both the very first true interval, the very last true interval, and all potential true intervals in between. So if both of these are true, then we're going to print Y. However, if all of these are false, so if both cases end up being false, then we just print no. And this completes the program. So once you've identified sort of the important variables here, doing the casework is fairly straightforward. The hard part of this question is coming up with what things are important to look at. And again, that's when you're going to want to break out the pencil and paper. All right, we're now ready to submit our code to the grading server. Let's get going here. There are a lot of test cases on this one, so I might jump cut. And we're back, and we can see that all test cases have been passed. So thank you guys so much for watching the video, and I'll see you guys in the next one. Bye-bye.